Today's lesson we're going to learn how to graph using slope-intercept form instead of using a table. So today we're going to be introduced to an equation called the slope-intercept form. The reason it's called slope-intercept form is because we're going to talk about the slope, which is also known as the steepness, or two words associated with it would be considered rise over run. The intercept is an intercept where the graph crosses one of the axes. And we're going to talk today about the y-intercept. Okay? So the equation is called the slope-intercept form because it deals with the slope and the y-intercept. So the equation that we're going to learn today is y equals mx plus b. We've worked with this equation the last few days. We've just been using tables. So what happens is m is going to be considered the slope. It's also going to be referenced as rise over run. How far do you rise and how far do you run? This is an up and down motion. Rise is up and down. Run is left and right. B is the y-intercept, where the graph crosses the y-axis. So we're going to use the equation y equals mx plus b in order to graph without using a table. So let's look at the first example. So we have y equals x. This is the most basic equation. This is also known as a parent equation. Parents are the most basic of equations. You can also think of this as the equation y equals 1x plus 0. So that fits into the y equals mx plus b form. The slope in this equation would be the coefficient of x. The coefficient is the number multiplied by x, so the slope here would be 1. The y-intercept would be 0. So then what you do is you come over to the graph. You're going to work alphabetically, b, then m. So b comes first. b is the y-intercept. The y-intercept is where it crosses the y-axis. The y-axis goes up and down. The x-axis goes left and right. So the y-intercept is where the graph will cross the y-axis at 0. So there's 0. The slope is how you go to the next point. You rise over run. The problem is this isn't a fraction. So we can make any number a fraction by putting it 1 over 1. So what we do is the slope is the roadmap. How do you get from here to the next point? You rise 1 and you run 1. Then if you want to do another point, because we did 3 points on our table, we rise 1 and we run 1. We rise 1 and we run 1 until we get at least 3 points, and then we connect the dots. We go past our last point and we put the arrows on. Okay? So let's look at another example. This equation, y equals mx plus b. What is the slope of this equation? The slope would be 1, because remember, there's a 1 in front of that x. This y-intercept would be 3. So I work backwards. I work with the b first. That's the y-intercept. Find 3 on the y-axis. You go up to positive 3, and then the slope is 1 over 1. Rise over run. Rise 1, run 1. Rise 1, run 1. And you get this graph. Okay, you'd get the same thing if you used a table, but this is a lot quicker if you know how to do it this way. Okay, here the slope would be 1/2. The y-intercept would be 1. We haven't dealt with fractions yet. Doing the tables, we had to make sure we picked right ordered pair or right numbers to plug in so we could avoid the fractions. The fraction 1/2 is actually really easy to deal with in the slope-intercept form. 1/2 is the slope. The y-intercept is 1. So we go to the y-intercept of 1. We put that on the graph. Then the slope tells me to rise 1, run 2. Rise 1, run 2. And notice how this graph is going uphill from left to right. That's a positive slope. The slope here is positive. The positive slope. That means you have done it right. Okay? Now, our slope here is -3. And our y-intercept is 2. So again, y-intercept, positive 2. And then we have a negative slope. So we make a -3 over 1. So that tells me rise -3. So a negative movement would be down 1, down 2, down 3, right 1. Notice only one of these two numbers is negative. So you have one negative movement, one positive movement. And then you can go down 3, right 1, and you would have a line that looks something like this. Okay? And this slope from left to right is going down, which would be a negative slope. So then let's look at the next one. The slope would be -3/4. The y-intercept is -2. So we go to -2 on the y-axis, put our point. Then we have a slope of -3/4. That means to rise -3, run 1, 2, 3, and 4. One movement is negative, one movement is positive, which means I could also make this a 3/-4, because it's still going to be a negative result, which means I would +3, -4, and notice that gives me the same line. So it doesn't matter which one you put as negative, because a positive divided by a negative is a negative. A negative divided by a positive is a negative. The slope over here is a negative, so that tells me I have done everything correctly.